All right, we're on page 3 of the study guide. Question 29, you're asked to identify the radius and center of the circle and then graph it. So I would always identify the radius and center first. Let's write up at the top, x minus h squared plus y minus k squared equals r squared. And the most common mistake people make is they're going to tell me that radius is 9. But r squared is equal to 9. So you have to take the square root of that. R is the square root of 9, which is 3. So our radius is 3. And then don't forget the sign change for our center. It's at positive 3, comma, negative 3. So positive, comma, negative. All right, then to graph it, we go over to 3, negative 3, put our center. And then you just have to plot 4 points. So 1, 2, 3, 1, 1, 2, 3, 1, 2, 3. Okay. And then you just kind of sketch the rest of the circle. This part's hard. I'm not very good at sketching circles. But it should look something like that, as long as the center and radius can be discerned from your sketch. Okay, question 30, similar question. This time you're given the center. Ooh, this page is a lot like the mile marker. You're given the center and the radius, and you are asked to write the equation and graph it. So again, we said we take our center, but we remember that the signs change. So this becomes x minus 2 squared plus, in parentheses, y minus 3 squared. And then it's not equal to the radius, but it's equal to the radius squared. So if r is 5, r squared is 25. So this all equals 25. All right, then when we go to graph it, we'll plot our center. So I'll go to 2, comma 3, and then I'll use the radius of 5 to come up with my other 4 points. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. And then again, we'll just kind of sketch our circle as long as those 4 points. Don't not sketch the circle, though. I would not give you credit if you don't sketch it, but I know it's hard to do. All right, that's question 30. Moving on to 31. Given the equation x minus 4 squared plus y plus 4 squared equals 4, somebody loves 4, does the point negative 1, comma 0 lie inside, on, or outside the circle, and prove it algebraically? This is a great critical thinking question. So really, we know we could figure out the radius of the circle, we can figure out the center of the circle, and then we know that point. So we could figure out the distance from the center to that point and see if it's equal to the radius, greater than, or less than. So looking at this, if r squared is 4, and that's just from my equation, r squared is 4, that means the radius is the square root of 4. So the radius is 2. So from the center, if you just kind of imagine a circle, from the center, if you go 2 units in any direction, if you arrive at a point, you're going to be on the circle. If you go less than that distance, you would be in the circle, and if you go more than that distance, you would be out of the circle. So if we know our center, and just from looking at an equation, I can see my center is at positive 4, comma, negative 4. All we have to do is figure out, is this point exactly 2 units away, more than 2, or less than 2? So we could do that with the Pythagorean Theorem. So if I think about it, or the distance formula, but I'm really just asking you to find the distance between these 2 points. So if I just kind of graph this or sketch this graph, see, 1, 2, 3, 4, 1, 2, 3, 4. My center is at 4, negative 4. The point is at negative 1, 0. You can probably already guess your answer, but we need to be precise here. And we're going to use the Pythagorean theorem because we have to prove it algebraically. So graphing it is proving it graphically. All right, and our question is basically, is PC equal to R? Or is it from the point to the center greater than R? Or is it from the point to the center less than the radius R? So this is what we're trying to figure out. Which of these statements is true? All right, so we said that this was at 1, 0, or negative 1, 0. So from negative 1 on my x-axis over here to positive 4, that's a change of 5. And from my y values, negative 4 up to 0, that's a change of 4. So when we do the Pythagorean theorem, we do 4 squared plus 5 squared equals, and this is where we're finding PC squared. I'm going to just call this x. So x squared. So this is 16 plus 25. So 25, 31, 41. And so the square root of 41 is equal to x. And you ask yourself, is that number more than 2, equal to 2, or less than 2? And hopefully that's obviously more than 2, because 2 squared is 4, and 41 is a lot bigger than 4. In fact, if you plug that in your calculator, that number is around 6.4. Okay, so it turns out that this length is longer than our radius. So that means, if you think about it, the radius of the circle is only 2. So our circle's like down here. This point is outside the circle. All right, so point negative 1, 0 lies outside the circle. And our evidence for that is the work that we showed when we basically did the Pythagorean theorem and then reasoned about that. So outside. I love that question. All right, question 32. Given the endpoints of the diameter, negative 3, 5, and 4, 2, use the distance formula. And the distance formula, we really just use the Pythagorean theorem and the midpoint formula to find the radius, find the center, and write the equation of a circle. So remember, the endpoints of the diameter, those are points on the circle. Something you need to keep in mind is that the midpoint of the diameter is always the center of the circle. All right, so the midpoint of the diameter is always the center of the circle. Okay, so if we have the diameter, I don't know why, I just want to find that one first. So if we put our endpoints into this table, so we've got negative 3 and 5, and this is like an XY table. And then our other endpoint is 4 and 2. The midpoint is going to be the point exactly in between those numbers. So from 5 to get to 2, I'm going down by 3. Half of that, I would go down by 1.5. So if I subtract 1.5, I get 3.5. And then from negative 3 to 4, that's an increase of 7. So I want to increase half of that. And if I increase by 3.5, I get positive 1/2 or positive 0.5 here. So that midpoint is my center. So we just found that it's at positive 0.5, 3.5, or 1/2, 3.5. All right, the radius is going to be the distance from the center to the end point. So now that we know the center, we can basically, we're going to plug that into the Pythagorean theorem. And it helps me to just sketch where this would be on the graph. So if I think about it, positive 1/2, So maybe if this is 1/1/2, comma 3.5, I'm going to imagine that point's about here, and that's the center of our circle. And then I could pick any of either this point or this point to basically be the point I'm looking for. So 4, comma 2 would be like right here. And this is going to be a point on the circle. So my circle goes around like that. That's an endpoint of the diameter. Okay, so if we just use the Pythagorean theorem, we can find the radius. So from, and again, we said that the y-coordinate of this is 3.5, and then the y-coordinate down here is 2. So this is a change of 1.5. And then from our x-coordinate, 1/2 or 0.5, to this x-coordinate, which is 4. Sorry, I had a spaced out for a minute. That's going to be a change of 3.5. The numbers you get here to plug in to the Pythagorean theorem should be the same numbers you moved by in your table. So to find that radius, we're going to do 1.5 squared plus 3.5 squared. That'll give us the radius squared. All right, so definitely we want to use our calculator since we've got decimals, or at least I do. 1.5 squared plus 3.5 squared, I get 14.5 is my r squared value. And then if I take the square root of that to find the radius is approximately 3.808. So for the radius, we would say 3.808. All right. So now when we go to write the equation, be careful. We're going to plug in our center. So x minus 0.5, you could also use 1/2, plus y minus 3.5, or 3.5, or 7/2. Now, it's not equal to 3.808. It's equal to the radius squared, which is 14.5. So be careful there. But it's equal to 14.5.